we're going to be taking a look at approximating square roots of non-perfect squares. So, for example, what is the value of the square root of 31? If you enter it in your calculator, it is approximately 5.56776436. But how can we estimate the square root of 31 if there is no calculator available? So let's talk a little bit about this. This is a non-terminating, non-repeating decimal. The square root of 31 is called an irrational number. It is a number that you cannot write as a fraction. So an excellent way, if we are going to try to estimate the square root of 31, an excellent way to do this is to use the square root of perfect squares. And what do we know? We know the square root of perfect squares, and we call these benchmarks. So benchmarks is simply using information that you know to approximate information that you don't know. So it might be handy if you write this on a piece of paper. In the top row, these are all square roots of perfect squares. So for example, 1 is a perfect square, 4 is a perfect square. So the square root of 1 is 1. Square root of 4 is 2. Square root of 9, that is also a perfect square. That result is 3. And so on. I would pause the video right now. Make sure that you write all of these down and make sure that you're able to reproduce this. Largely, this is what we're going to do. So I trust that you paused the video. You wrote these down. Allow me to go back to this. So let's consider the square root of 31. We look at the radicand, which is 31, and what we know is 31 is not a perfect square. If this was, for example, the square root of 36, I would know the square root. If it was the square root of 4, I would know the square root. What makes this difficult is that the number underneath the radical, underneath the square root, is not a perfect square. So perfect squares tend to be 1, 4, 2 times 2, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, 25, and so on. Exactly what you wrote before. The square root of these perfect squares are like this. So if you wrote out what we did previously over here, you'll likely be in good shape. Now, let's consider the square root of 31. So do I know the square root of 31? 31. I do not. But I do know the square root of 36. In other words, I take this radicand and I choose, if I can, the next highest perfect square. Now, there are some subtleties to this, but the next highest perfect square to 31 is 36. I know that number. Now, I want to ask myself, what is the perfect square that is next smallest to 31? And that is 25. So I know that the square root of 31 is stuck between these two values. The square root of 25 is 5. Square root of 36 is 6. So I know that the square root of 31 is being between 5 and 6. And if we dig a little bit deeper, 31 is 6 away from 25, and 31 is 5 away from 36. So 31 is almost in the middle of 25 and 36. So I would estimate that it might be somewhere in the middle. The square root of 31 is 5.5. Now this little symbol that I've used is not necessary to put down, but it just means approximately. So if you look back at my value that I used earlier, it's pretty close. It is a very good estimate. Now I'll go on to the next example. Now remember what we tried to do. There is something I forgot though. If I go all the way back here, I think I may have forgotten the first perfect square. And the first perfect square is actually 0. The square root of 0 is actually 0. That might come in handy a little bit later. So now we're going to determine the approximate value of 71. The approximate value of the square root of 71. So the first thing I'm going to do is simply write the square root of 71. And then I'm going to try to pick the next perfect square just below 71. So I look on my magic list, and what is the perfect square that is next lowest to 71? It's actually 64. And then I look for the perfect square that is greater than 71. It's 81. So if I take a look at this, I know that 71, the square root of 71, is going to fit somewhere in between these two perfect squares. And that's what I've tried to communicate here. And I know that 64, the square root of 64 is 8. The square root of 81 is 9. So the square root of 71 is somewhere between 8 and 9. It's a pretty good estimate, isn't it? Now, I'll try to go a little bit deeper. So 71, so is it 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7? Well, if you notice, 71 is 7 units away from 64. 71 is 10 units away from 81. So I would suspect that it's going to be 81. So it's going to be closer to 8 than it is to 9. So I'm going to estimate 8.4 because it's almost in the middle still. That would be my approximate value. Now, if curiosity strikes you, by the way, by all means, grab a calculator, figure it out. Now, allow me to do the square root of some terrible, awful fraction. The square root of 6 over 13. Now, you may want to stop and think about what is the square root of 6 over 13. Now, we're only thinking about approximate values. Did you know that 6 over 13 is approximately a half? So what I'm going to do is I'm going to think of the perfect square that's immediately below. And that would be the square root of 0. I'm going to think of the perfect square immediately above, which is 1. So the square root of 6 over 13 lies almost exactly in the middle between the square root of 0 and 1. So 0 and 1. And I know that this is going to be approximately 0.5. Now, believe it or not, experience tells me that this is a bad estimate. The real value is around 0.8. But it's really not that important to get an exact value. We're just looking for approximate values. Last but not least, well, for this video anyways, the square root of 19 over 6. Now we are trying to approximate this. So I'm thinking to myself, what is 19 over 6? Well, 19 over 6 is actually the square root of 3 and 1/6 if you decide to change it. It's the square root of 3 point something. So I'm just going to try to benchmark this. And what do we mean by benchmark? Is that we pick landmarks that are perfect squares. The perfect square that is below 3.3 and 1/6 is 1. The perfect square that is above 3 and 1/6 is 4. Square root of 4, pardon me. So I know that 3 and 1/6, the square root of 3 and 1/6, is much closer to 4 than it is to 1. So the square root of 1 is 1. The square root of 4 is 2. What I would suspect is that the square root of 19 over 6, or 3 and 1/6, is going to be very close to 2. So I'm going to say 1.8. That would be my guess, because 1.8 is much closer to 2 than it is to 1.